Okay, let's write web server in C. But why in C, you might ask? Because by writing a web server in C, we'll be able to understand how things work at the low level. So instead of writing on something like Go, Python or JavaScript, we'll be forced to understand how the TCP sockets work, how the HTTP works, how the web server communication works at a very low level. So that is the idea of this exercise. So just a reminder, the goal of this project is not to come up with the production ready web server or something like that. It's just to learn and understand. So I'm kind of new to this, so I'm going through some online resources. This looks kind of interesting, this Medium article, and I already referred some code in ChatGPT and some other resources. So let's see what we can do. So I already have a project started. So it has a make file which defines how to build this application. So we are going to have two source files, main.c and webserver.c, and it's going to create an executable called the web server. Okay, so when we run make, it's going to compile these two files into web server. Now let's create those files and see if it works. So let's see, let's do a stdio. Let's try to do a hello world first. Okay, coming to my terminal. Make works. As you can see, when I run make, it uses GCC to compile these two files into the object files, and then finally it becomes this web server. If I do make run, it prints hello world, so all good. So now we need to figure out how to create the web server. So my idea is to split this into two files. So we'll have most of the web server logic in this C code. This we can make it a bit more portable and hopefully use it in any other application if needed. And the main.c will keep it very simple. Okay, and of course we also need a web server.h where we are going to declare all the methods present in web server.c, which can be imported in main.c. Okay, so let's get started from here. So as a good practice, we have to make sure that this is not imported multiple times. So we had to do is ndf server.h. Okay, and then so this will make sure that whatever we define inside this block will be only defined once, even if this header file is imported multiple times in different files. Okay, so first of all we need a struct for holding the server variables. So I'm gonna call it struct server. Okay, and so we are going to operate on this web server structure. So first of all we need a method which will accept some parameters and return a web server struct. So let's do something like this: web server create, and it can take port number as an argument. We'll see if we need anything else later. So now we need to do web server run, which will take this web server as an argument. Okay, sorry. So this will create a web server. So inside this we are going to initialize the socket, variables, etc., and this structure will keep hold of the file descriptor and whatever it requires for the web server. And then in the web server run, it's going to start the server and listen for connections. Okay, now in the web server.c we can start defining the methods. Okay, so first we need to define the web server structure. So what do we need? We need a port number, we need a server file descriptor, we also need to keep track of the address which the server is listening at. So let's do okay, so we need to import a few header files for this. Let's do the header files a bit later. Let's define how this web server create will look like. So this will take a port number. So I'm only accepting port number as an argument because I'm going to listen to all interfaces in the local server. So it only requires port, and we are going to do only IPv4. Let's define this web server structure. We need to create it, of course. So define the memory for the web server structure. Then I need a server FD. This is the file descriptor for the server. So what I need to do is server FD equals to socket. So this will create a socket. Let me refer and make sure I'm doing it correctly. So I need to create a socket for which can communicate across internet, and it uses sock stream, which means it's a TCP connection. Okay, so let's do that. Okay. So this will try to create a socket and return the file descriptor. So this file descriptor is something which we use to write and read data from. So with this file descriptor we can communicate through the socket as if we are reading from a file. So we are going to check if it returns a file descriptor which is less than 0, which indicates that it's an error, and if it's an error we should return null, because this method accepts web server pointer as a return argument. So at this point we have a server socket. Now there's something we need to do. We need to set some parameters for the socket so that it can reuse the port number. So basically if I am running this application and if I close this, what's going to happen is that the socket is going to stay there for a while, so I won't be able to listen to the same port number if I start the application again. So to avoid that conflict, I'm going to set some option. So I need to do set sock opt. So this will set it to allow using the address, and we need to set the option number somewhere. I honestly don't know what this means, but this is required. Okay. So if that is not successful, we close the server file descriptor and return. So to explain again what happened here, so here we are opening a file descriptor and here we are closing it. So imagine we close the application without closing the file descriptor, so that file is going to stay in the system, which means if we started listening for connections and we kind of close the application without closing the socket, it's going to stay there for a while until somebody cleans it up. So which means if you start the application the second time, it will throw an error saying that the port number is already in use. So with this option, we are saying that if there's a socket which is assigned to this process previously, let's reuse it. Okay, so I'm just gonna fill a few things. I'm just gonna return this here. We have a few more things to do here, set the address and everything, but let's prepare the skeleton first. We also need the web server. Let's do it web server. Not fun. So it takes a web server as an argument. Let's return 0 for now, and let's start using it in Android C and compile it and see if it works. So we need to do web server. Okay, first we need to include the header file. Create. So we need to define the port number. Let's do 10,000. Okay, so this won't do anything at the moment, but let's see if it works by compiling it. It won't work for sure because we haven't completed the imports. Make, of course, when I'm including a local file, it should be enclosed quotes. Okay, now we need to import all the things we need. Interesting. Oh yeah, we need to. Sorry, we need to include hash include server.h. This will. Then for the socketer we need. What do we need? We need this socket. We need. Okay. Less errors. Web server create. Okay, forgot the semicolon as usual. Whew. Unknown type name web server. Web server. Isn't it fun to write in C? Implicit declaration function malloc. Of course, for malloc we need stdlib. And for p error it's stdio. For close we need uni std. Unused parameter port, that's fine. Unused parameter, okay. Okay, so we have it compiled. Now let's start working on the remaining part. Okay, let's back to our web server create. What else do we need? So we have the set options. Now we need to set the address for the socket and start listening for connections. To set the address, we need the struct sock_addr_in. So this is where you can store the IP address. So first we need the cyan family. So this is going to be FINet. So this means it's an IPv4 internet protocol. If it's an IPv6, I think it's going to be a FINet 6 or something like that. Anyway, so we also need to set the IP address. So this will make sure that we are going to listen to all interfaces. If we need to bind to this particular IP address or interface, we need to specify it here. So for now I'm going to listen to all interfaces. That means if I get a request in whether through Wi-Fi or internet or LAN or localhost or whatever, it's going to respond. Okay, so what else do we need? The port number. So we need to do STO and specify the port number. So we have the address now. We are not binding the address yet until we start the server, so we just save the address in the structure so that we can use it when the server is started. Okay, so we do web server FD. Of course we need to save the server FD, then the port number and the address. So that's all we are going to do in the create method. So this will initialize the socket, set the options, and save the file descriptor for socket, port number and address in the structure. This is going to be returned to the caller, and whenever we are ready to start the server, it's going to use this to start listening. Okay, let's compile and make sure we are not missing anything. Just a warning, so we're good. Coming to the web server run method. So first of all we need to bind the socket into this particular address. So let's do that. So for binding I need to use the server file descriptor. So this is a bit tricky. Starter. Error is just to output in the standard error. So if this will try to bind the server to the address we specified above, which is listening in all interfaces with this port, and if it fails it will just print that it failed and return. Let's do -1 instead, so we can use it as like an exit code. Okay, so we are going to bind it, and let's try a make here. Incompatible. Okay, because it expects a struct socketer. Alright, we just have to cast it. Okay, now what? This is a pointer. Perfect. Now it's bound. We can start listening now. Listen. Server FD. So we need to provide the queue size. So this means the server is going to listen now, and it's going to take at most 3 connections at a time in the queue. Okay, and if the listening failed, we have to do p error forgot to close the server here, and sorry, return. So at this point the server started listening. Let's see how good. It's not doing anything yet. We can do a print actually. Print f the server listening on port. Okay, that's good. /n. So now we can start accepting connections and receiving messages from the socket. Let's do an infinite loop. See. So we need a structure to store the client address. So struct sock address in client address. Okay. We also need to store the length of the client address. I don't know why. Okay. Also the file descriptor for the client. So this is where we are going to store the file descriptor when connecting to the client, and we can use this to write and receive messages from the client. Okay, now we can start accepting the connections. So okay, client f, come on, accept connection from the server. So it needs a few more parameters here. Okay. So client we need to pass a pointer to the client address so that when we accept the connection, it can store that client address information here. And of course we need to cast it to sock address pointer because that's what it accepts. And we also need to pass the client address length. Okay, here we have the accept, and once it is, if it is an error, we're going to print an error as usual. Okay, so let's look at it again. So here it's going to accept a connection from the server socket, and we pass a pointer to the client address structure. So when the client makes a connection, it's going to accept it and store the client information in this structure. We also need to pass the length of this structure because it accepts a sock address pointer instead of sock address in pointer. So this way, so the way it works is there is a high level structure called a sock address, and then there are multiple substructure. I would say it's more like an inheritance. Then we have sock address in and a different one for IPv6, and there can be different implementation of the sock address structure. So we cast it to sock cutter pointer because this method only cares about uh, the fields in this structure. So if this is, let's say, 10 bytes, if this structure, let's say, 10 bytes long, maybe the first 5 bytes will belong to the fields corresponding to this structure. So that's why we are casting it and then passing the length of this here. So we have the connection, we got the file descriptor. Okay, now we can start receiving and sending messages to this file descriptor to talk to the client. Okay, before that, let's print the incoming connection IP address and port number. So we have that information. Let's to make sure that it works. So let's do IP address char. So this will create a string, and the length of the string will be the length of IPv4 address. This is where we can store the address of the client. So we need to use a function called inetntop. Client address header. So this will convert this SYN address structure into a human readable string and store it in this array. Okay, now we can print it. Print code connection from host name and port. Okay, IP address and web server port. Perfect. Let's see if it works. Absolutely no. So we have finet should be a pointer. IPASTR. Woohoo! So we have a server listening. What do we need? Let's make a request, and it's frozen. Of course, we are not responding anything back from the server, and we are not closing it. So the client is just waiting for a response, and the server just accepted and then doing nothing. Okay. So the server is still here and the print already happened, but it has not flushed it to stdout. So if I close this and nothing works, let's do one thing. Let's close the client here. Okay, that's something. So it's now returning an empty reply from server, but it's not printing it because we'll have to flush it. stdout is buffering the strings, and since we are still technically inside the method, it hasn't flushed it. That's why. So if we flush it, we should see connection from, oh wait a second, it's printing the server port, but what we need is the client port. Client address. Okay, so when a client makes a request to the server, there is a source port from the client and a destination port on the server. So the destination port is the port where it is listening on. Perfect. So this is the source port. If I do another request, each time it will be a different port. And I forgot the /n. Awesome. Now we have something. Let's try to make a git commit. Listen and exit. Okay. Alright, looking good now. Now we should start reading the messages in the server. Let's take a break and continue in a different video.